Hello, welcome to this other tutorial. So this is functions. Okay, so we have the function h, which is defined by h of x is equal to 2/3. Then this is an absolute function of x minus 1 plus 7. Okay, sketch the graph of h of x. So how do we sketch this graph? All right, so what we can do here is that, all right, we first have to recognize the fact that this is an absolute function. All right, and we know that an absolute function of x, let's say, it will always give you a v shape of type of a graph, right? All right, now let me take you back to secondary. You remember this equation, right? Do you recall it? And if I make y the sum of the formula, I'll be getting this. Okay, notice anything similar here? Yes, the number in front here, 2/3, is actually our gradient. And x minus 1 is what we have in the brackets, and plus 1 here plus y1 is just 7, which is just the intercept. All right, now what does this number tell you about the graph? It shifts the graph upwards because it is positive, so it's going to shift the graph 7 units upwards. And the number in here, it is responsible for the horizontal shift. All right, so set this equal to 0. In fact, if you want, you can set everything there equal to 0. So you set 2/3, just say x minus 1 equal to 0. You're getting x equal to 1. Now that we get x equal to 1, what is the corresponding value of h or y? So you go back, you say h of 1, 2/3, 1 minus 1 plus 7. So you're getting h of 1 as what? 7. So this point is what we're calling the vertex. So the vertex is at 1,7. Are we there, right? Then you have the vertical shift. The vertical shift is 7 units up. Okay. Then the horizontal shift is just 1 unit to the right. Take note of that. So how do we make sure that we balance this? We can pick any 2 points from either side. Remember that we are having a V shape, right? So we can pick a point from that side and a point from this side. We taste. So let's do that. If I pick, let's say I pick, okay, I'll just be picking points, right? If I pick x equal to 4, for example, which is like the other side, the right side, right? What is the corresponding value of y in this case? So we say h of 4 is equal to 2/3, 4 minus 1 plus 7. And when you work out this, because this is a 3 and 3 cancel, 2 and 7, you get 9. So we have 4,9. We get another point, the other side of the graph, which is the negative part. For example, just assuming you get -2. So we find h of -2. This will give us this, -2 minus 1 plus 7. This and that cancel, and we are still getting 9. Isn't it? Because remember, that's just the absolute value. In fact, it's like this. Now, the absolute value of a negative number, it will always be a positive number. This is still giving us 9. So we're still arriving at the same, the highest point here is 9. In the numbers that we've picked, it is what? 9. So how exactly is this 9 helping us? Well, it is just helping us to say, no matter how far I go, I'll reach 9. So coming to sketching of this graph, to be like this. So here we have x. Don't put y here. Here we've got h, by the way. So we know that we have 1 here, all right? Then we have a 7 somewhere there. So this is a turning point, the vertex. So that is a point we are saying the graph is going up and this other side. Then we had something like 4,9. So we can put our 9 there, such that maybe we can put our 4 here. Can I be realistic a bit? Okay. So we can put our 1 here, then our 4 there. All right, yeah, I think that's better. Then we can do this. Okay. Then we can just put our 9 there and maybe our 7 there. So we have this point here, 1,7. So we can just put it there. Okay. And we've got another point here, 4,1. So we can just put it somewhere there, 4,9. And the other one is actually negative 2,9. So somewhere there. So you see how the graph is going, right? It's going like this. It's a V-shaped type of a graph. Like that. Where the gradient, remember, is this side. Remember that it's going up. So the gradient here is 2/3. But the gradient here, because the line is slanting down, it will be negative 2/3. So this is just an illustration of the graph, how it's supposed to be. Okay, it will be a V shape. I may not have drawn it properly, but it depending on your scale. But keep in mind, this is how the graph is supposed to come out. Then we go to part 2, which says state the domain and the range. So how do we get the domain and the range? First, what is a domain? A domain is just a set of values, a set of all real numbers that define a function. Now, an absolute function, take note that an absolute function is actually defined for all real numbers of x in that x-axis. Therefore, we are saying the domain is just negative infinity all the way to positive what? Infinity. That is the domain in the x-axis. What about the range? Now, there's a way you can represent domain and range. You can use different methods. You can use the set period notation or interval notation. It's up to what you decide. Now, let's look at the range. The range is what you get when you put in domain values into the function. And the lowest number we are getting is actually 7. Taking note that our function is starting here. So our lowest number is 7. That is our lowest number in terms of range is 7. And the highest, as it told you where it's ending, it can be going and going and going. So that's why we are saying for the range, 7 is inclusive and it can go all the way up to positive infinity in the y-axis, just like that, and you're done. 3. Why the function where give reasons why h to the power negative 1, which is the inverse of h, does not exist. Why doesn't h exist? Well, we need to take note that for a function to have an inverse, it must be what? There's a condition for a function to be an inverse, to have an inverse. It must be 1 to 1. So for a function, okay, to have an inverse, it must be 1 to 1. All right. Why? Why do you think it should be 1 to 1? Because each value of y corresponds to exactly one value of x. You can't have a situation where when I put in a value of y into a function, then I'm getting 2 values of x. That's not a 1-to-1 function. And this is a case in our function. Remember that we are dealing with a modulus. A modulus of a function will always give you a negative number and a positive number. And we don't want this. A function which shows this is not 1-to-1, hence it cannot have an inverse. For a function to have an inverse, it should be 1-to-1. And when I put one value of y or x, should only give me one value of the other. Okay? Not a situation where when I put, for example, 2 in the function, okay, I'm getting 2 values. For example, in our case, we've got h equal to 2 over 3, then this, then plus 7, right? If I put 2 here, if I put, let's say, negative 2, I'm going to take 2 conditions. I can say it will be 2 over 3, then I'll say negative 2 minus 1 plus 7. Or I can say 2 over 3. Now, take note, a modulus will always have a positive and a negative part, right? Now, everything here can be negative or positive. Where here I'm going to get 2 over 3, but this one will still remain negative. But here it will be 2 over 3. This will still remain positive. This is why we are saying you are getting 2 different values of h. Because of that, this cannot be cannot have an inverse. By the way, I think I've explained enough. Just give that reason of 1 to 1. So since now we can now conclude. Since h of x is not a 1-to-1 function, it cannot have an inverse. We are done. We can now move on to part 4. Solve the equation h of x is equal to 6. We are saying h of x is equal to 6. All right, let's solve. So we are saying 2 over 3 modulus of x minus 1 plus 7 is equal to 6. Now, remember that we are going to have, we remove 7 both sides. So if I say I subtract 7 here and I subtract 7 here, I'll be getting something to do with 2 over 3 modulus of x is equal to negative what? 1. All right. So now, you can multiply both sides by 2 over 3, right? So we multiply by 3 over 2 and this side by 3 over 2. So we get 1 minus, sorry, x minus 1 is equal to negative 3 over 2. Now, now here's the key. You can never get a negative number when talking about an absolute function. Let me tell you this. What is the absolute value of 2? It's still 2, right? What's the absolute value of negative 2? It's still 2. Are you getting a negative? No. So because of this, all right, we are going to say you can never have, once you have a function like this and there's a negative number at the end, don't even bother solving it. Just write a conclusion. Just say the absolute value, this is always positive. Is always what? Positive, or you can say it's always non-negative, depending on what you are comfortable to use, right? But this, but negative 3 over 2 is less than 0, right? This is less than 0, which is impossible. Which is what? Impossible. Therefore, there is no solution. Avoid just saying there is no solution. Give a reason why there is no solution. The absolute value you state, which one are you dealing with? I'm dealing with that one, is always positive or non-negative. But what you have is actually less than 0. Therefore, conclude there is no solution. Don't just go there and say there is no solution. All right. I'll see you in another tutorial.